thermal conductivity derivation to na kan lo so yanga thermal conductivity chu ten ka se hal mo menga e thir glass slab mo slab cube shape in glass pon che lawang chu metal thir ani ma zo gang chu consider a slab having parallel faces a thu hi chu ti hianin kazia lang ve vak lem lawa tia ka explain na mathematical lai hi karon tilang chianga a thu akara je tur zeu ang zia tel ngai thi nang hi chu tinge ka tiang akara zia tel ngai thi nang hi tian atong ka yin tin ka soi thi na ni chu kha lo hre thin ula kara zia zeu tur kha chu in hre thiam tho ka ringa te ka zia ve ka thu jong ne na ka zia na rei thi na video hi tuan a mathematical lai ringot ka ti lana wang khan exam na po khanin a mathematical lai ringot to na ka cho ka derive chu angai lo ti ve ringot khan ma ka scoring lutuk lo mai theya a thu kha chu kar la ka ze ve zeu kha chu tul thin tho ti khai no hre thiam don in lo hre don ne chu in hre thiam na tangin a kar ze tur kha chu mani hre thiam na tangin mani onward te pon in lo zep ve zeu anga I explain na ang kha chu chuanin thermal conductivity hi chu hey glass slab ka ti zia chu cube shape in thirom ta se consider a slab having parallel faces mo chuanin helampang hi a area hi a ni ta sela a area a ni ta sela helampang po cube ani mi wa area a tho kha ni don ta chon helampang banga hi helam bang le lama hi hot face lampang zo kha ni ta se temperature T1 chon heat kha in transfer phei don ta ni flow of heat kha don ta chuan helampang bang opposite face hi cold face zo ka khani ta se abang vot lampang zot kha temperature T2 ni ta sela chuanin khata kan han mu chuak ta ka chu to na mi ro jong po kha onward dang khan in soi thei don ta chuan to na kan han mu chhuat ta ka chu it is found that hemi heat kala kha hemi heat flow kha heat flowing kha kan thil mu chhuat ta ka chu ten hai poi thuwa zia tur kha chu thozana zia tel thema se mathematical lai chau ka soyanga it is found that the heat q kha kan mang thina symbol q hi it is directly proportional to the amount of heat flowing is directly proportional to the area hemi abang len lo wazir khan ani alen that viau chona sa po kha petnem don ti na ni mai a q pakhat tet viau chonin alum pon ne panga asane panga chuwan chon q is directly proportional to the area chuan kan hmu chhole dang boka chu q is directly proportional to temperature difference hemi an temperature in thlauna ka hi lo sa ta viau ta se hi lo vot ta viau ta box se chuanin an heat kha an heat flow khu atam don ti na ni mai a difference kha hot face le cold face in thlau viau chon a heat kal za thi tam don ti na alo in thlau viau lawal hepo hi alum over lo hepo vot over lo angte in temperature in nai deuh te ni kha chuanin a heat kala po khatam over thei lo kha tiang kha ni mai ta chuan a temperature difference T1 le T2 in subtract a value tam dana zirin anin thlau dan anin vo hlei dan amo anin sat hlei dana zirin a heat tam lo kha hril ta ni chuanin q chu a time taken hana hril bok ta hemi akal chunga kha chuan q hi it is all in at the top na ber hi chu it is inversely proportional ani thung tonga 1 by anga la ngai ta thickness of the slab mo d kho thickness ani ta hemi hi cha viau chon a breadth ani chu hemi in kar a travel na to in kar thui viau chuanin heat ava pek chung po kha rei don ti na ni ta chuan hemi a thickness hemi te bang pani hi anin nai viau chuanin heat ponin petnem theyanga ma se azau chuan heat atam ve sot don lawa tlem sot thung dona chuwang chuan inversely proportional khani tani thickness mo chon hemi te pali hi kan han combine vek khan a t1 minus t2 t by d along ni tani hemi equation pali ho hi ten ka combine ta vek d hi chu hnuaia ta chuanin hemi proportionality hi equal to kan thla dong han constant term k kan da ta a chu he constant term k taka hi coefficient of thermal conductivity ti chu tu na kan thupui hi lo ni ta ni coefficient of thermal conductivity. This constant term k is what we call coefficient of thermal conductivity. Chuanin hemi a value hi he k value hi a fixed value ani velem lawa fixed takani lawa adang lam theya hemi slab material azir hian ani all athir material copper po ni theya iron po ni se khamia zira a material azir khanin hemi k value hi chu dang lam thei ta ni tichon he equation hi enta wang taila hi equation 1 lo pe taila he equation 1 hi enta wang taila he equation 1 na hian area hi 1 ni ta se area hi 1 centimeter square mo 1 meter square po lo ni ta se a unit value lo ni ta se mo e hi chuan a temperature difference te po hi T1 minus T2 te po hi 1 ni ta se 1 degree chau ni ta se 1 degree Celsius example a chuan time taken a po hi 1 second 1 ang vek khan lo chang ta se la a distance hemi thickness of the slab po hi 1 meter emo 1 centimeter lek ni ta se vai hian 1 ni ta vek seng chuan heng value area te heng ho zong hi 1 ni vek seng chuan q hian nge tluk ta kang if mo hi 1 ni vek seng chuan q hi k tluk don ti ani me ta chan chu heng ho zong adang zong 1 an ni chuan chu ta tak chuan thermal conductivity k a chu a definition kha a heng ho mang khanin a define thei don ta ni coefficient of thermal conductivity chu lo define thei don ta chuan kan define thei dana chuan coefficient of thermal conductivity is defined as the amount of heat. So heat na equal to pot ta tro coefficient of thermal conductivity may be defined as the amount of heat energy that flows in a time kha ti hitan bet letter ka mga time that flows in unit time unit ka ti hian in a tongkam define na hen 1 na soina ni unit chu 1 na soina ni that flows in one time ti kha adik amoy lawa unit ti kha kan mang thina 1 soina chuan the coefficient of thermal thus we can define the coefficient of thermal conductivity as the amount of heat energy q kha heat energy that flows in unit time okay 1 ani kha chuan that flows in unit time between the opposite faces of a cube of a side a distance akha 1 ani ta box ta se ter of unit side ani let me a side akha 1 a value 1 ni ta se of unit side made of material and the faces are kept at a temperature difference po kha 1 ani each one the faces the opposite faces are kept at 1 degree difference mo 1 degree temperature difference or 1 degree difference of temperature tikha and having unit area te po khati khan heng ho zong unit area le 1 temperature difference 1 degree and time also unit time and distance between them is also and the distance between them is also unit khatyang zong ani khan thermal conductivity kha qnen thermal conductivity kha heat energy nen ain tluk ta ni cho a define dan cho ni mai han so equal thui do kha aola a ol ang ain coefficient of thermal conductivity of a material may be defined as the quantity of heat energy that flows in unit time between the opposite faces of a cube of unit side made of that material, the faces being kept at 1 degree difference of temperature. Chuanin hemi heat flow hemi question in taile hemi heat flow heat lian over ni lo ta se small heat ni ta se if small amount of heat flows chu lo ni ta se chuan a time taken po hi re lo ta se second cut ling mang lo te lo ni ta se small time lo ni bok ta se hemi hi small heat le small time al kan lo ngai chuan equation 1 hi alo zia danglam thei ta hi dq kan hmanga hi tan dt kan hmang bokanga small heat le small time mang lo ni ta seng chuan so if small amount of heat flows dq is equal to ka t1 minus t2, and if it also takes small time more, dt by d. Chuan hemi dt hi heta ka son thanga dq noya, it will go down. Dq by dt is equal to ka t1 minus t2 by d. Lonita ni equation 2 lonita sela. Chuan in shed turbo chu het lai chin t1 minus t2 by d ti lai akhu. t1 minus t2 by d hi temperature hemi bang vot atanga bang sa atanga bang vot kal chak zong ani ta ni is the rate. It is the t1 minus t2 by d hi hey adi kha distance kha ni bok ta tero acha zong kha ni ta thickness kha. Chuan temperature difference by distance ani. So it is the rate of fall of temperature tlak niam chak zong ani chu he asa kha avot tul don ni chu chan chu heta zuk transfer wang kha hei salo tul don ta. It is the rate, the speed and it's of the fall of temperature with distance between them, between the two faces mo. Chu taka chu he taka hi temperature gradient ti lo ni ta ni chu ming define na chuan he t1 minus t2 by d is the fall of temperature between the two faces, and it is called temperature gradient ti ni ta ni. Chuan in temperature fall, temperature hi chu heta t1 atanga t2 a heta amalum na khap ape pheizel don ta ni avota han chuan temperature khatla niam don tina ni ta helam hot phase atang khan amalum na kha ta fall of heat oma wangin flow of heat oma wang khan atla niam don tina ni ta chu taka chu a temperature tla niam chu a value hi dt ni ta se. If dt is the temperature fall, more temperature tla niam zat kha dt ni ta se. Chuan a distance apo kha hemi in car apo hi dx ni ta se. If dt is if the temperature falls by an amount dt, temperature tla niam zat kha dt ni ta se. Chuan flow of heat direction akala a distance thui zong kha dx ni ta se. Chuan he thil temperature gradient hi t1 minus t2 by d hi dt by dx ti ang chuan alo zia the mai ta he t1 minus t2 chu temperature difference a fall na zat kha ni ta a tlak niam na zat chuan d kha distance kha ta tero chuan distance dx lo ni ta bok ta se kan ti kha ni ta ni. Chuan hemi le equation 2 chu ending elo equation 2 will become equation 2 kanan substitute chuan hemi hi equation 2 a kanan substitute chuan dq by dt is equal to ka dt minus t by d khai mi hi ni ta tero ka dt by dx alo ni ta ma se ta hian minus kan tel don ta ni. Engatinge minus kan tel na chan chu negative sign shows that the heat flows in the direction opposite to that in which the temperature gradient increases. Omzia chuan temperature gradient value hi a increase na direction zok he temperature gradient increase na direction opposite in heat kha kalawangin temperature increase na direction opposite zela heat kha a flow awangin negative kan da ani hemi negative hi chuanin a value aron ti tlem sot ton hemi value hi ron ti tlem sot ton ti na lampo ni chuang lawa direction ron entir na mai ni chuanin he equation a hi dq by dt equals to minus ka dt by dx ti a hi heat kal chak zong hemi parallel phase in kara heat the rate of flow of heat chak zong taka chu speed taka chu he equation atang hian kan nei thei ta ni chu he equation hian alon entir ta ni chu ron represent ta a. Chuanin ISI unit ang zong chuan thermal conductivity hi joule per second per meter per kelvin tinia. Chuan CGS ang zong chuan calorie per second per centimeter square per degree Celsius. Anyway, thongdan joule kha calorie ya second hi chu second ala ni thau CGS pon ma meter kha centimeter a kelvin kha degree Celsius sa. Chuan kha jong kha thermal conductivity chuan me 3 mm lo aneu kha om ve nuala ma se han har sa mm om shan lo. Chuan kan thupuin dot le hian WIENS Wein's displacement law kan ziranga Wein's displacement point till 3 mm ani lem lawa. Wein's displacement law she thiam main black body perfect black body hi enge ni kha sei le lokela perfect black body kan ti chuan perfect black body kan ti chuan those kind of bodies which absorbs light of all wavelengths vibrio khan shiatero vibgyor vibrio te hi hei violet hi a deflect na saberta prism glass 1090 khan then a deflect andron deflect bezel thoma se red te hi deflect na saber to lo ta ni deflect the least kan ti to ta ma se an wavelength lambda khani come on wavelength value chu violet hi anei tlem beranga least wavelength ania red hi will have maximum value of lambda chuanin kha object na zong hianin ni inan khami radiation vibrio ina an chhun hian object na zong hianin an lo absorb an lo emit vek thei lo ta ni heng different spectrum of light ho hi ma se object then khat lo absorb kim vek thei heng radiation pasari chisari rong chisari ina wavelength chisari ina an chhuna lo absorb kim vek thei hi alo aom ta ni chu taka chu black body ho chun ni ta ni perfect example a chu enge example a kan lak theyang teeth cavity hey in ha pui te po in anterior dentist hey engamani light ray engmo radiation ina an chhun thin hitero ha dentist pan thang chuan in hrianga khata an chhun kha engma kha reflect om lo tero in ha khan hengma in cavity khan engma reflect lo chuan in teeth cavity te hi perfect black body ni chanchu khatiang light zong kha lo absorb emit vek thei energy lo emit vek thei amaro chu energy emit vek kan ti wang khan an wavelength ta zirin an emit zat energy ya khachu ain ang vek chuang lo violet le red kha I emit ve nangin a value I energy emit zata kha energy lo emit zata kha ain ang ti na poni chuang lo adang lam fur tho chu shet to ni ta chuanin Wein's displacement law chon kan lut tonga Wein's displacement law ina sei taka chu lambda m in t mo lambda mt hi b ani ti zong ani ta hi mathematically enge omzia he b ya hi Wein's constant ani ta ni he small letter b hi Wein's constant ani ta a value po a fixed value ne 0.002898 meter kelvin ani ta ni 0.002898 chuanin enge omzia ber chu light spectrum howa kha anon emit khan chu teeth cavity ya khan example a yellow kha eta vibrio a yellow kha low energy low emit number lo ni ta se kha wavelength on wavelength value point ang lo vek ta tro kha yellow wavelength khan in energy low emit number ni ta se example a mo maximum energy lo peta chu taka chu he hi ni ta ni the product of the maximum wavelength emitted by a black body and the absolute and the temperature of that body ama body in ha temperature ani chu ber na khami ama temperature shim a body temperature a black body temperature shim le hemi maximum a wavelength ina maximum energy ya emit value in multiply kha constant term ani tini mai chu Wein's displacement law ina so yani ta chuan so constant chu b ani ta chu Wein's constant continue chu the maximum energy emitted by the wavelength of a black body and the absolute temperature, the temperature of that body, of that black body. If we take the product, it will be constant term. Chuan last Stephen's law oma Stephen's law page chu harlo Stephen's law in chuan ange so Stephen's law ina soi chu black body ina a energy pek chwa zata hi more energy emitted energy per second per unit area anti deuh khera per second tina second khat dan zela an energy black body ina a energy pek chwa hi second khat dana square meter khat dan zel a thlapa energy pek black body ina perfect black body ina a energy pek chwa zata hi that energy is directly proportional to the fourth power of the temperature of the absolute temperature. Amzia chon kha black body temperature kha black body temperature it cavity I ha temperature anyang te ponyang chu kha black body temperature kha to the power 4 in la chocolate ta ila chumi le kha black body na a energy pek chwa za ta kha a in proportional atina ni ta ni chuan chu Stephen's law ina soizong chu ni ta ni the energy per second per unit area of a perfect black body is directly proportional to the fourth power of the absolute temperature ti khani ta chuan or we can write E is equal to sigma t to the power 4 hemi sigma tak constant term tak hi Stephen's constant ti alone ta bok ta chuan Stephen's constant value hi fixed value ne hi po hi 5.67 SI unit ang zong chuan 10 to the power minus 8 ani ta ni Stephen's constant hi joule per second per meter per Kelvin to the power 4 chuan CGS ang zong chuan 5.67 into 10 to the power minus 5 ani thunga ni mai chuan arch per second per centimeter per Kelvin to the power 4 hemi unit hi chu in triat pol veo chuna point lawa hemi a unit hemi a number hi poimo ma jok ani hemi komi number hriat chen ko Stephen's constant